Hello everyone, and welcome back to the Fluctus Channel. Tactical vehicles serve as indispensable tools that guarantee the success of demanding missions carried out under extreme conditions. These rugged machines are engineered for durability and adaptability, enabling them to traverse landscapes that ordinary vehicles could never handle. Whether operating through the thick woodlands of Europe or the blistering deserts of the Middle East, these vehicles meet the harshest environments head-on, with one of the toughest challenges being river crossings. Such deep water passages not only reveal the capability of the machines, but also put the driver's expertise to the test. These strenuous maneuvers, where vehicles negotiate aquatic obstacles, are collectively referred to as fording. This process is vital not only for carrying out direct combat operations, but also for ensuring safe movement of supplies and personnel when bridges are damaged or completely absent. Fording is a routine part of both military training and real-world missions, offering mobility and an element of surprise. This capability becomes essential in areas where bodies of water cut across primary operational zones, creating obstacles that can also serve as tactical advantages when leveraged effectively. Before these armored giants take on the dangers of a deep water crossing, careful preparations are required to protect the vehicle and guarantee mission success. Every component, from the oil fill caps and dipsticks to the transmission dipstick and sealing points, is inspected. The transmission dipstick and seal must be secured. If they are not tight, the vehicle's reliability cannot be ensured. Technicians also confirm that all battery caps are fastened, connections are secure, and terminal bolts are properly tightened. Fuel caps are sealed firmly, and cargo must either be waterproofed or removed to prevent damage during the crossing. Doors are detached, and windows are kept open to reduce potential hazards as the vehicle enters the water. Before the mission begins, the water depth is measured to confirm it remains under 60 inches, which is the safe operating limit for most tactical vehicles. Any submerged rocks or obstacles must also be cleared to allow an unobstructed route. Once these steps are completed, the vehicle is readied for fording. The forward vent switch is set to deep fording mode, and non-essential systems, such as heaters and lights, are turned off to conserve electrical power and reduce risks of malfunction.
So at this point, we're going to wait till all the water fills completely into the back and all the side compartments. Go ahead and go!
During the crossing itself, as the vehicle moves into deep water, these precautions ensure the process stays controlled and effective. Immediately after the vehicle exits the water, crews work quickly to drain any remaining water. Important follow-up checks include inspecting all oil reservoirs to detect water infiltration or discoloration, helping maintain the vehicle in peak condition for future missions. It is essential to highlight the adaptability of U.S. Marine tactical vehicles during amphibious missions. Beyond traditional ground operations, these vehicles play a major role in amphibious operations, particularly in the AAV launch from ships. Officially known as the Assault Amphibious Vehicle, AAV, and previously designated LVTP-7, it has long served as one of the United States Marine Corps' most powerful assets in Amelia, receiving continuous upgrades since its introduction in 1972. The AAV transports Marines directly onto beaches during amphibious assaults. Once the operation begins, the assault and landing proceed swiftly without troops needing to pause at the shoreline. Alongside AAVs, the Marine Corps also relies on Landing Craft Air Cushion, LCAC vehicles, as a crucial part of its amphibious force. The LCAC is a hovercraft capable of rapid and efficient movement of personnel, heavy equipment, and vehicles from ship to shore. Riding on an air cushion, it glides over water surfaces, making it ideal for environments where obstacles or shallow areas hinder conventional landing craft. This flexibility allows nations operating LCACs to deploy and extract forces quickly, greatly enhancing responsiveness during amphibious assaults and disaster relief missions. Picture a convoy of heavily armored vehicles approaching the daunting natural barrier of a river. While this might appear impossible, the United States Army has faced such obstacles with unwavering resolve and remarkable ingenuity. In military history, wet gap crossing operations have stood out for their ability to transform natural obstacles into strategic access points. During the Second World War, European rivers like the Meuse, Moselle, and Rhine became major barriers for Allied forces. Despite the difficulty, the U.S. Army succeeded in crossing the 300-foot-wide Moselle River and capturing Nancy in France. Later, crossing the Rhine River became the Allies' crucial route into Germany, as it represented the final major natural barrier. These crossings marked significant turning points in the Allied advance. Unlike dry gap crossings, wet gap crossings leave convoys exposed on the bridge, with no cover from enemy fire. To counter this, engineers construct a bridgehead on the far bank, offering protection and serving as a staging ground for additional forces. To begin the crossing, troops assault across the river to establish a foothold and secure a protective perimeter. Once stabilized, the position becomes a fortified bridgehead, and engineers construct a bridge across the gap. After the bridge is in place, artillery, armored units, and advancing forces strengthen the position and push beyond the bridgehead. Although wet gap crossings involve multiple branches working together, multi-role bridge companies form the backbone of these operations. Their skill in assembling temporary and semi-permanent bridges is crucial to mission success. While rapid river crossings require fewer resources, deliberate crossings often call for constructing a full bridge across the gap. As their name suggests, multi-role bridge companies handle a wide range of tasks during gap crossing missions. In some cases, engineers must construct temporary or semi-permanent bridges. When this is not practical, they turn to floating or raft bridges. Factors such as river width, bank stability, and enemy resistance determine which method is most appropriate. Constructing a bridge is no simple task. The M30 bridge erection boats, or BEBs, serve as essential tools for assembling floating bridges and conducting rafting operations. These boats can reach virtually any location, as they may be transported by road, sea, or air. When moved on land, they are carried using the common bridge transporter. Built with an aluminum hull, the M30 BEB is powered by 2 diesel engines. These engines operate a water jet propulsion system, enabling the boat to function in shallow waters and areas with high particulate levels. The system also grants impressive maneuverability, allowing the boat to move forward, backward, and even laterally. Thanks to this capability, the boat plays a crucial role in deploying ribbon bridges. The improved ribbon bridge, or IRB, represents the latest version of ribbon bridges capable of serving as floating bridges or rafts for vehicle transport. The main component of an IRB is a modular bay. Multiple interior bay units are linked together and paired with ramp bays at each end. A ramp bay can reach banks as high as 2 meters. On land, these modules are transported using a common bridge transporter or a palletized load system truck. Their folding system opens automatically once released into the water. After a bay unit enters the water, bridge erection boats secure it with ropes and maneuver it into position to assemble the bridge. Although these bridges are designed to handle heavy loads, their limits are pushed to the extreme when massive vehicles like the M1 Abrams cross them. Engineers at the U.S. Army Engineer Research and Development Center are responsible for testing and analyzing the IRB's load-bearing capacity under such weight. Using a scaled-down M1 Abrams and IRB model, they study hydrodynamic forces and then apply the findings to real-world improvements. The Armored Vehicle Launched Bridge, or AVLB, is vital for ensuring the continuous progress of forces across varied battlefield conditions. The M60 AVLB derives its name from the M60 tank chassis it uses. Its hull supports a launcher connected to the bridge. This scissor-style bridge measures 60 feet in length and is deployed or retrieved quickly using hydraulic systems. Folded sections are stored atop the hull. Deployment takes only minutes, and the bridge can be recovered from either side. To position the bridge, the vehicle is parked at the riverbank, and the overhead cylinder extends the launcher upward, setting the rectangular outrigger on the ground. The outrigger stabilizes the AVLB while the bridge is extended. The tongue cylinder then unfolds the bridge completely. After placement, the vehicle reverses and automatically detaches via a quick disconnect mechanism. For retrieval, the overhead cylinder extends again, and the vehicle drives forward to reconnect the two halves before the bridge is lifted back onto the hull. The bridge supports a military load capacity rating of 70 when covering a 15-meter gap, with crossing speeds kept below 8 miles per hour. Powered by a robust 750 horsepower diesel engine and operated by a two-person crew, the AVLB proves valuable beyond combat scenarios, offering essential aid during natural disasters due to its versatility and efficiency. As today's operational landscape continues to evolve, one principle remains constant. Mobility forms the foundation of every effective military force. Whether advancing through hostile terrain, overcoming natural barriers, or supporting amphibious missions, the United States Armed Forces depend on an exceptional combination of engineering, innovation, and human expertise to keep every mission moving forward. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.